Hey guys, for our first episode, we're going to dive into the exciting and developing idea of mRNA vaccines. Alright, now before we get into the topic, let's break down the name mRNA vaccine. Well, do you guys know what a vaccine is? A vaccine is something administered to a patient to give them immunity from a disease. While this may be a simple definition, it is all we need currently for our topic. So let's dig into the more complex part of this topic, the mRNA part. Okay, so before I explain what mRNA is, I'll give you some context on its original form, DNA. So, DNA itself, the basis of our existence, it codes for our traits using four nucleotides. Take these nucleotides as the most basic and essential part of DNA. DNA stores our genetic info in patterns of its nucleotide sequences. Now, I know it's a mouthful, but I'll explain what I mean by that. You probably know that DNA has two strands, right? We've all seen those images of the DNA which has a complex double helix structure. So these two strands are connected by these nucleotides. There are four nucleotides in total: adenine, guanine, cytosine, and thymine. Adenine is attached to thymine, and cytosine can attach to guanine. Each nucleotide can pair and bond only with its corresponding one. Suppose I have adenine in spot 2 of strand A and thymine in spot 2 of strand B. These two strands will be able to attach together since the corresponding nucleotides are in the same position on either strand. Just to be clear, nucleotides do not store any information, and the sequences of these nucleotides is where the genetic information is stored. Okay, so you guys got that much? If not, make sure you go over it again, since this plays a key role in understanding the basis of mRNA. Okay, so now what I want you guys to do is think of DNA as computer code. You have all your code ready, but you haven't executed it yet. The DNA executes its code to make proteins using the nucleotide sequence. In the first step of executing this code, the DNA is copied in a form called messenger RNA, or better known as mRNA. Exactly what we wanted. Now, there are some key differences between RNA and DNA, even if the nucleotide sequence is the same. DNA stands for deoxyribonucleic acid. However, RNA stands for ribonucleic acid. As the name implies, there is a difference in the sugar of the backbone. DNA has the deoxyribose sugar in its backbone, whereas RNA has a ribose sugar in its backbone. Another key difference between the genetic structures is that thymine in DNA becomes uracil in RNA. Alright, so since you got that, before we dive into the mechanisms of the mRNA vaccine, let me give you a basic idea on how it works. So, researchers create an artificial small segment of viral mRNA. This mRNA is then administered to the patient. The cell uses the nucleotide sequence of the mRNA to create a harmless protein. The immune system then detects this foreign protein and develops antibodies against this viral strain. So, if the person were to ever contract the disease, they would easily be able to overcome it.